Okay, done. Okay. Oh, Zara is here. Okay, hey Zara, back. Now, everybody back, yeah? So let's look at the screen. Now, I was telling you just now that using this table is not going to give you mark, yeah? Okay, writing the table of values is not going to give you mark. You just need to get the graph out. So I tell students, don't depend on the table. You need to half out the shape of the graph. So for cost graph, the shape of the graph will look like this. When x is 0, y is 1. So you start on top. When x is 90, y is 0. So when x is 180, y is -1. When x is 270, y is 0, and 360 is 1. So the graph, look up, it looked like a smiley face graph, right? Look like you can draw a smiley face. It is not a smiley face, not a quadratic graph. You have to draw the graph in this particular shape. You have to curve it up and then draw it down and then bring it up and then go that way. So do not draw this quadratic shape. You will get it wrong. In a way, this graph, for those of you who take bio, this looks like the uterus connected to the ovary. Or if you don't take bio and you don't know how the uterus is drawn in the reproductive system, you can think of this as the panty. It's a panty shape, G-string. Okay, so the cost graph will always look like this, and this is one cycle. All right, please remember that. Okay, so we'll do tangent next class because now I want to teach you the transformation. Okay, teach you the transformation of graphs. Yeah, so let's look at that. Now, for those of you who are copying, I can't check what you're copying, but I want your graph to be drawn exactly like mine. That means you don't go curi tulang and then skip the 90, 180 or whatever, yeah? Get your shape out and the points all put properly. Transformation of Trigo graphs. Now, there are 5 transformations for SPM syllabus, okay? There are actually 6, but you have 5 only. And you can have combinations. I'm going to teach you one by one, but you may have combination of transformation. So the first one is amplitude. Okay, so the amplitude punya transformation will be like that. Let's use the cost graph. So let's say 3 cos x. Okay, or y equals to 2 sin x. Okay, let's put, yeah, okay, 2 sin x. So do you see, now here is where it is important that you look back at the format just now. A sin x, sin bx, bx plus c. Remember, we did this just now, up there, where A stands for amplitude. So I have changed the amplitude now. It was a 1. The basic graph is always a 1. Your amplitude is a 1, the basic graph. But now we change it, it's been transformed. The amplitude is now 3 and 2. Okay, so in this case, amplitude is 3. In this case, amplitude is 2. So what we're gonna do is you just draw the same thing, yeah? So we draw the cost graph first. Okay, so same thing, the way to draw, please follow and listen to me when I explain to you how to draw the graphs. Otherwise, you're not going to know how to draw it later. Okay, don't just copy me, listen to my explanation. So you draw your graph, sama saja the way, you break the graph into 4 equal parts. Okay, this is not long enough, we'll lengthen it. So 4 equal parts, and then you label 90, 180, 270, and 360. Okay, and now the amplitude is 3. So you don't have to write 1, 2, 3. You can just put 3 here, doesn't matter, and you put -3. So the point 3 and -3, you just need to show. Then you draw your cost graph. Remember the cost graph, how it looks like? When x is 0, it's always going to be 1. But instead of 1, it will be 3 now because the amplitude is changed. So you just plot. Okay, so you just put a point here, 3. And then when x is 90, it will always be 0. So 0, no change. 180, instead of -1, it becomes -3 because the amplitude has changed. 270 is 0 and 360 is 3. So if you and compare, be smart, don't just copy, okay? If you look and compare, you realize that it is the same. The shape of the graph is going to be the same. The only difference is instead of writing 1, you put 3 and -3 because the amplitude changed. So it's really actually quite simple. Then now we draw the panty. Okay, please try to draw it nicely. Okay, so that is amplitude. That's the easiest transformation ever. Huh? Okay, so now let's do when the amplitude is 2 for sine graph. Oh, okay, God, how to draw a straight line. Okay, so same thing here. Okay, so cut the graph into 4 equal parts at your x-axis. Okay, generally that's how it is: 90, 180, 270, and 360. Now instead of putting 3, you put a 2. Then you remember how the shape of the sine graph look like, right? The sine graph starts at 0. The next part goes up to 1. Instead of 1 is a 2. 180 is at 0, so bump up. You get a bump up, you can see it. And 270 instead of -1 is -2. 360 is 0. So you get a bump up, and then you get a bump down, and you go up. Finish. So amplitude punya transformation, very easy. You just change the labeling on your y-axis. Is everyone clear?
Yes. Yeah.
Okay. Okay, period is the hardest, huh? Okay, so let's start with y equals to cos 2x. Okay, period, I have to give you a few examples, yeah? Period is one of the hardest one because period can have a lot of changes, okay? What cos 2x? Yes, but just shit a bit. What do you mean just shit a bit? You want me to move up, is it? Can't shit a bit, need to shit all. You want me to move up, is it? Shift up, is it? Is that what you're saying? Good God. Imagine this is recorded. But yeah, it's in the middle of the video. So nobody's gonna get here.
Teacher, can I copy later and just listen to you now?
No. Oh, why? Because it takes a long time. Is it, Ken? Sure.
Yeah.
Sure. You can copy later based on the, you want to look back at the video, is it? I can
No,
send you
I'll
the
screenshot.
Yeah, okay, screenshot. Good. Okay, so can I explain the period then? Yeah, that's a good idea. All right. Please make sure you copy, yeah, and don't wait so long because you will have Dory syndrome. Okay. Now, remember that period means how many cycle in 360. So again, recall the basic graph. The basic graph, I just put y equals to cos x, where if you notice, the coefficient of x is 1. That means 1 cycle in 360. But if I have not 1, but 2 or 3 or whatever, so you have 2 here, that would mean that we need to do 2 cycle in 360. You understand that? 2 cycle means you're going to draw 2 panties in 360. Can you see that your cos graph, normally we draw 1 panty in 360? So if you have a cos 2x, it means that you got to squeeze 2 panties into 360. So how are you going to do that? You're going to make it narrow. So I'm going to show you using the laser, yeah? So you basically need to do 1 here, and then you need to do another one there. You understand? So how are we going to do that? It's just by using logic only. You don't need a table of value. Some teachers will teach you using table of values. Do not do that because you cannot see the shape properly. Trust me. Later, there'll be more transformation. Always transform from your original basic graph. You will understand me later when we continue on. So what happened now is the way to do is this, yeah. 2 cycle in 360 means you're going to do 1 cycle in 360 bahagi 2 lah, correct? So you get 180. So that means you're going to draw 1 panty in 180. So the way to do is the same thing, yeah. Let's cut the graph now into half as usual, but draw the graph a little bit longer because you're going to try to squeeze 2 panties into 360. So it's going to be like you need it a bit stretched, so you don't have to squeeze your graph so much. Now, instead of putting 90 as 2 boxes, you just make your 90 to be a bit longer. So each of them, so maybe I just put 90 here, 180, 270, and maybe lengthen it a bit, and this is 360. Okay, because I want to squeeze the graph into 180, so that's why I'm making the scale a little bit bigger. It's just to make my own drawing easier. And what's the amplitude here? Okay, what's the amplitude here? The amplitude is 1, yeah? I didn't do anything to the amplitude. So since the amplitude is 1, then you just draw the highest point as 1 and the lowest point as -1. Okay? This is the very first thing you need to do when you are sketching graph. Get the scale out and get the scale, as in the y-axis and the x-axis out. Okay, and understand it. Otherwise, you will be like stuck, oh, I don't know how to start it. Right, now, next is this. How does the cost graph look like? The cost graph starts at 1, right? Okay, so before we do that, you know that you are going to have one graph in 180. So what I want you to do now is just look at the screen. It's just look at this 180 sahaja. Cut the graph into half at 180. And what I want you to do is this. Remember that your graph is drawn based on 4 parts on the x-axis. Remember, your graph has got 4 bahagian, right? So between 0 to 90, we're going to cut into half again. Okay, you understand? That means you have 1, 2, 3, 4. 4 parts in the x-axis so that you can draw your cost graph. So how do we do that? Same thing now. When it is 0, the points, we are plotting points. We're not plotting, we're plotting the shape. So follow this. The first point is up there. So we're going to put the first point up here. Okay, so first point. Second point will be at the x-axis 0. 90, it will be at -1, and this will be 0, and this will be here. Can you see it now? I'm plotting the exact same point. Exact same point. You get it? Like a V shape. And I'm putting it in between 180 because I want to fit one cycle into 180. That's what it means. Then I connect. Oh, so ugly. No, I don't like it. I'm going to connect. Why does it shift that way? Okay, all right. And then we do the same thing for the next block, 180 to 360. You will get another cost graph, another panty. We're going to draw that. So over here, and you need 4 bahagian on the x-axis, right? So we're going to cut this into half again. You get it? And then we're going to sambung. Okay, so we are going to plot the same thing, the V shape, the 5 points. Okay, so 1, 2, 3, 4, 5. Can you see it? So plot that down, -1, 0, and 1. So then you sambung. So can you see by doing this, you can get 2 cost graph in 360, and it's nice and evenly distributed. You don't need table of values because if you do it this way, you understand perfectly what the transformation means. If you put table of values, you will have to plot 45, 90, 135, 180, 225. That is a lot of work. And after you plot, you don't really understand what you're doing to the graph. Now you understand that I am expanding the graph into 2, putting into the same 360 degree. Get it?
Miss Ang?
Yeah.
I don't understand the logic of doing it, of cutting 360 divided by 2 equals 180.
Here, do you understand that do you understand that 1 panty normally fits 360?
Yeah.
But if I say I want to fit 2, because it's 2x, 2x means I need to make 2 oscillation in 360. So that means I need to make 1 oscillation in 180, right? Do you understand?
No. What does that mean?
Really? This is a okay, it means that, remember, you need to go 1 round. Okay, just remember, okay, just think of it like that. If you don't understand the cycle thingy, you just think that I need to draw the cost graph. Instead of 1 in 360, I need to fit it in, I need to fit 2 into 360. So you're squeezing, you're trying to make more in 360 degree. So if I do 2 in 360, means I need to draw 1 of them in 180, right? My space. So in other words, right, I'm actually supposed to be doing this, okay? I'm supposed to be doing this. If I were to show you, I'm supposed to be doing this. Can you see this up here? Wait for the screen a bit. Sarah, look up here. Can you see the black color graph? I'm supposed to be squeezing 1 penty and 2 penty into 360. Do you understand? So I'm actually narrowing the graph. So this is called a transformation of graph. I'm just squeezing it so that I have 2 or instead of 1. So I'm trying to fit 2 of them into 360. So that's why I bahagi 2. Do you understand? Imagine you cycle 1 round in 360. Now I want you to cycle 2 rounds. So you have to make one round in 180, isn't it? Do you understand?
No, not really. I don't understand what's the point of it.
The point, there's no point. The point is just telling you to cycle faster, make more oscillation. This is actually a vibration. It's actually a bit to do with physics as well. So it's like you, instead of vibrating 1 round in 360, you need to vibrate 2. So it's like making it faster. Usually for those of you who wonder what application is this, this is actually has to do with frequency. That's why you have an alternating current graph. So imagine this, Zara. Normally, okay, imagine this, normally you make 1 round in, let's say, 360 degrees. Think of it as time, as time. So instead of making 1 round, okay, cycling 1 round, you need to cycle 2 rounds within that same time. So that means you have to do faster, isn't it? So to do faster is illustrated by drawing 2 of it in 360. So you can't show time, you can't show how fast you do by drawing, isn't it? So you show by the number of the drawings in 360. So instead of 1 penty, you draw 2 in 360, telling yourself that you are doing double the speed.
Okay, right.
In the same time. You get it? Yeah, so this has, actually it's a very good question, because this is where if you convert to alternating current graph, then it makes the frequency higher. For those of you doing physics, so the current has got a higher frequency. So yeah. Okay, now let's move on. Any other question, guys? Even Hannah Zara never think of asking me like that. But yeah, when she watched the video, maybe she'll be like, okay. Now let's do 3x. Okay, so that means what they're doing is they're asking you now, move faster. I want 3 cycle in 360. It's always 360. Your time is fixed at 360 degree, 1 unit circle, 1 rotation. Okay, so you need to make 3 rotation in 1 circle, 3 times, 3 rounds in 1 circle. Okay, so y is equals to, why am I writing this? So 3x, 3x means 3 cycle in 360. This is always the first thing you do, because you need to know 1 cycle berapa is 120. Oh, later you ask me mana dapat 120. Okay, this is what Haziq is going to do. 360 bagi 3, you get 120. That means, and remember how your sine graph look like? Okay, I'm just going to show you briefly. After a while, you pandai already, you will know. 1 sine graph is 1, let's use a different color. 1 sine graph is 1 bump up, 1 bump down. That is 1 sine graph. Okay, then what you need to do is now you need to draw 3 of them. So another 1 bump of this, can you see that? And you need to finish at 360. Okay, so that means your frequency is 3. You have increased it 3 kali ganda. You make 3 oscillation in the same time. So 360. Now let's look. That means, right, every cycle must be 120. Makes sense, right? You can even sketch it roughly in your head already. So this is the only graph. You don't do 90, 180, 270, 360, but rather, okay, so we draw it nicely over here. Okay, cut the graph into half. Maybe over here, make it a little bit longer so you don't have to draw really hard. Okay, and maybe every, oh shit, what am I doing? Okay, so let's do 120. Okay, no, 4 of them. 120, 240, and 360. Oh, I don't even need that much. Okay, so let's write 120, 240, 360. Does that make sense to you? Zara, do you understand? But, hi dear, do you guys understand why it's 120, 240, and 360? It's in the increment of 120 lah. One cycle every 120. Okay, okay, good. Now amplitude is 1. Okay, let's change it. Why don't I put the amplitude as 2? So no difference, what? You just put 2 here and put -2 there. Okay, now listen. Remember to make one sine graph, the bump up and bump down, you need 4 bahagian. Remember, 4 equal parts. So what I'm going to do is I'm going to bahagi my 120 in between into 4 equal parts. So 1, 2, 3, 4. Can you see the blue color one? And I'm going to plot the points for the sine graph. It is important that you understand the points for the sine graph. Where is it? Okay, if you look at the points for the sine graph up here, okay, isn't it 1 point here, 1 point here, up, then bump down? Get it? So 1, 2, 3, 4, 5 points. The points will always be the same one for sine graph, okay? So then we're going to do the same thing for this. Look, 0 here, 1 point here, and then you plot it up and down and down and up here. So then your graph will go this way. You need to plot, otherwise confirm you will be sengit. Do you understand? And then you do the same thing. Cut the other bahagian into 4 parts because you want to make another round. So up, down. Okay. So then it goes up and then it comes down. Okay, then cut the other part into 4 bahagian. And same thing here. Plot the same shape for the sine graph. There, nice and perfect. 2 sine 3x for 360. Question? Okay, let's do this, yeah? What about y equals to 4? Okay. So that means you are making half cycle in 360. So this dude is really slow. Normally people make 1 cycle in 360. Now he's gonna just do half. Get it? So he's slower. So that means you're gonna fit half the cost graph in 360. Think of just drawing half of this, okay? So like this, half of the panty in 360. So you always bring back to 1 cycle. So 1 cycle in 720, because you bring the 2 over. So you times it. So now we draw the same thing. Graph, straight line, cut into half. Okay. Now 4, that means you just put 4 and -4 as your amplitude. Amplitude is the easiest thing. All right. So you're going to draw 360. So my idea to you is this. You can skip this step if you don't want to, but it's easier for you to see. Yeah. Let's do 360. So 1, 2, 3, 4 boxes. 5, 6. Okay, like 4 boxes. Okay, 360. Okay, and then you have 720 here. Okay, but we are only interested in drawing half a cycle in 360. So what we will do is this, yeah? Remember, you are going to have 1 cycle in 720. This is much, much easier to do. If you do this, do 1 cycle. 1 cycle means you cut the graph into 4 equal parts from 0 to 720. So you cut another, you draw another bahagian here. Can you see? You understand that I want 4 parts from 360 to 720. Okay, we draw this first. And remember, we're drawing cos, so it's the panty. So we're gonna draw cos starts from here, okay, the 5 points, right? So you're gonna get a panty that looks like that, right? So we're gonna put in the points, so red color. Point 1 is up there in the middle, down here, there in the middle. So what you're gonna do is you're gonna get the panty that looks like this. But then remember that we are only going to draw until 360. The 720 is to help you because the graph is usually limited until 360. So what we're going to do is you're going to take your eraser. Oh, by the way, all your graph sketching must be using pencil. If I catch anyone sketching with a pen, I will ketuk the kepala. The y-axis, the x-axis, and everything is with pencil. Okay, so you will have no problem doing this, yeah? We're gonna erase this part. Oh no, so if I erase, it's gonna be that part. So I will draw it again. So you're gonna erase this and this 720, and you're gonna draw only until 360. So yeah. Okay, and this is so ugly, I cannot tahan. I'm gonna draw it again. Okay. All right, so all you need is to label 0 to 360. So if you want to make it look nicer, what's in between 360, 180? Yeah, so just like that. So can you see that you're drawing only half the cost graph until 360? Well, technically it goes up, but we don't draw the 720. That's just to help you. Okay, any questions so far? Okay, yeah. Now I want to teach one last part. The vertical translation, okay? No question, I'm going to teach the vertical translation. So y equals to cos x plus 2. Wrong. Not C anymore. Number 3, yeah? Vertical translation. There are 2 more that we haven't done, the modulus and the negative graph. We'll do that next week. So we do vertical translation first. So y equals to sine x plus 2 and part A, and y equals to cos x minus 3. So remember the general transformation punya bentuk. So it's A sine bx plus c, okay? So we have done the A, which is your amplitude, and then we have done the B, which is your period, which is cycle, how many cycles, and then now we are doing C. C plus C can be minus, yeah? So the plus C represent your vertical translation. What it means is you move the entire graph up or down. So you can write this down here, vertical translation. Okay, you move the graph up or down by C. By C, whatever your C is. So in this case, in 3A, y equals to sine x plus 2. Let's ask if you know this. Hi dear, what's the A in this case? Y equals to sine x plus 2. What's your A?
1.
Yes, A is 1. What's the B? B is also 1. And the C is 2. So you draw a normal sine graph first. This is what I want you to do. I don't want you to move first, because when you move, mostly something goes wrong. This is the part where students make the most mistake, and then they make mistake already. You don't realize one. When I see the question, when I see your answer, I will tell you it's wrong. And then you will ask me why? What is wrong? Because you can't see it. So I want you to do it the way I'm telling you to do it. Okay? Unless you're very good with your spatial mathematics that you can see. Some people are very good at it. They make very good architects. Okay, so, oh no. Okay, put it down. All right, so you realize that I'm changing my x-axis and putting it down instead of putting it in the middle. Why? Because plus 2, I'm going to put here, plus 2, or C is 2, means that the whole graph is moved up 2 units because it's plus 2. This one, okay, minus 3, it means the graph, okay, it means the graph is moved down 3 units because it's negative 3. So what I want you to do for now is to draw your original sine graph first. Original sine graph, amplitude is 1, negative 1, and 90, 180, 270, 360, okay, because the amplitude is the same. 270 and 360. So your original sine graph will look like this: 0, 1, 0, negative 1, 1. Okay, so you go up and you go down. Okay, bump up, bump down. Then what we're gonna do is we're gonna move every point up by 2. So don't erase first, move every point by 2. That means, oh no, no space. I just realized Okay, never mind. I'm just going to lengthen this because I don't have time anymore. Blue. Okay, so this is 1 and this is 2. 2, 3. So what we're going to do is this. Every point move up 1 position. So I'm going to use red color. 0 will go to 2. 1 will go to 3. Follow the point. 0 will go to 2 here. And -1 will go to 1. And 0 will go to 2. So can you see your new graph is over here? The other thing that I want you to move with this. This is really important. Draw with dotted line your x-axis. Because the x-axis is where the graph is sitting on. So you need a guideline. You're not moving the x-axis, you are virtually moving it. So the x-axis move up 0 to 2, isn't it? So dotted line, x-axis move up. Then you can see how your graph look up. 1 bump up, 1 bump down. Now you can draw. So bump up, and then bump down, and goes like that. Okay? After that, yes?
So the line in black is not what we draw.
No, the line in black is your original as a guide for you to see how you move it up. Then you padam the black line. But for the purpose of your note, don't padam the black line. Just put a note there and say, erase this in exam. Okay. Now, unless you can prove to me that you are very good with your moving of the graph, you're not allowed to straight away draw this up here. Because later you have combined transformation. That means you will have two oscillation. Oh, if you forget to erase, some teacher will -1 mark. Because he will ask you which is the correct one, and you during exam. Right, he's not going to know which is the correct one. So you have to erase to show the correct one. Now, some teachers allow if you draw the original as dotted. Okay, some teacher allow, some teacher will allow that if you draw your original as dotted. So that the actual answer is the red color one, the dotted one is your original graph, which you translate from. You understand? It's like transformation. You know, when you do enlargement in mod maths or rotation, you have your object. Object is A, and then after you enlarge, object is A prime. So you're allowed to, like, if you put dotted line, depends on the teacher. Okay? Okay, so now I want you to leave you guys with some homework, because next week we are going to do extra, like sambung somewhat, like we're going to combine the transformation. Okay. Okay, so homework. We haven't done the modulus and the negative. Okay. Page, what is that? 383. Okay, mine is 383. Someone please check what is self-assess 5.4. Okay, question 388. Okay, thanks. 388. Question 1 all 2 ABCD. Okay, 2 ABCD. Okay, now before we go, I'm going to show you one. Can everybody turn to this page? You can copy this later. If you screenshot it, you can copy the graph later. Okay, because if I wait for you to copy, it's going to take forever. So can all of you turn to page 388 now and look at question 1. Question 1 says, sketch the graph of each of the following trigonometric functions for when x is between 0 and 2 pi. So you notice that in question 1, they want you to sketch for when x is between 0 and 2 pi. Now, if you see this represents 360 degrees, but in radian. So that means you must label your graph in radian, not degree. So remember how I teach you, okay, to cut the graph into 4 parts, right? And then I ask you to label 90, 180, 270, and 360. So now instead of labeling that, you're going to need to write it in radian. So let's look at the graph of, okay, cos x plus 1. So if I write cos x plus 1, y equals 2. Okay, I'm doing 1D, cos x plus 1. So draw the original graph first. So that would be 1, 2, 3, 4. So that is pi over 2 pi, 3 over 2 pi, and 2 pi. How far this? Pi over 2 is 90, pi is 180, 3 over 2 pi is 270, 2 pi is 360. You did a bit of this earlier. Okay, and since this is the cos graph, and amplitude is 1, look at that, amplitude is 1, and then you're going to move it by 1 position up. Okay, so the highlight. I'm going to move it by 1 position up. So amplitude is 1, so we're going to just draw 1 here, negative 1 here, and the original cos graph will be 1 point here, 1 point here. Okay, get all the points. You can draw dotted line if you want to. Okay, I'm just going to draw the full line here. Okay, so this is the original graph, but that's not what you want. You want to move it up by 1 point. So use red color, all the points go up 1. Your x-axis also go up to 1. That's your x-axis. Okay, and then this is 1, so 2 here, and negative 1 go up to 0. Okay, so now we plot all the points, yeah? So this point goes up here, 0 goes to 1, negative 1 goes to 0, 0 goes to 1, and 1 goes to 2. So, okay, why do I have a point there? Okay, forget about this point. Okay, so let's draw this. Okay, then you can connect the points. So the red color points, yeah? Connect the red color points and then go up. After that, erase the black one or put in dotted line. Okay. Question? They're gonna kick me out like soon, the Zoom. So if it kicks me out, you can all go. You don't have to come in again, but just take note, take screenshots. I want question 1, all of them done. I've done 1D, so you just copy it or try to do it again, and then 2 ABCD. You have to understand this very well at the tips of a finger because you have 2 more transformation and you have combination of all the 5 transformations of graphs. And you have to sketch them in exam. Any question? Trisha, are you okay?
Yeah, all good.
Okay, good. Haziq, you okay?
Yes.
Right. Zara?
Yes.
Okay. Izzat, no problem, I hope. Okay.
We go now.
You want to go now? Okay, you can go. Yeah, you can go, okay? Please make sure you have copied everything, the graph. Otherwise, it's going to be difficult. So you can go. I will send the homework. I will send the homework right now before I forget. And then end up, Izzat will say like, oh, I checked the group and tak ada. Okay, bye.